Example, the base of a solid is the region enclosed by the parabolas y equals x squared and y equals 2 minus x squared. The cross sections of the solid perpendicular to the x-axis are squares. Find the volume of the solid. Whenever reasonable, I begin volume exercises by sketching the graphs of the functions. Here, the graphs are the parabola y equals x squared, that's the parabola opening upwards, and the parabola y equals 2 minus x squared, that is the downward facing parabola with the y-intercept at 2. The volume is the integral of the area of the cross-section bounded by the graphs. That is, we compute the volume as the integral from a to b of a of x, that's the formula of the area, dx. Before proceeding, we find the points of intersection of the two graphs for the bounds of integration. We'll set the two parabolas equal to each other. X squared equals 2 minus x squared. We'll set that equal to 0, so 0 is equal to 2 minus 2x squared. Factor out the 2 and then factor the difference of squares, so 0 is equal to 2 times the quantity 1 minus x times the quantity 1 plus x. The intersection points are at x equals -1 and at x equals 1. We mark the point of intersection as the ordered pair -1, +1 in the second quadrant, and in the first quadrant the point of intersection is denoted by the ordered pair 1, 1. Continuing, the volume we compute as the integral from a to b of a of x dx, and the cross section is a square. It's sketched in there kind of. The area of a square we know is a of x equals the length of side squared. So we need to compute the length of the side. The length of the side is the difference between the two parabolas. So we'll compute x squared minus the quantity 2 minus x squared, which equals 2x squared minus 2. That's the length of one side of the square. So the area of the square, a of x, is the quantity 2x squared minus 2 squared. Now we're ready to find the volume. We will integrate from -1 to 1, the points of intersection we previously found, and the formula for the area of the cross section, which is the quantity 2x squared minus 2 squared dx. Let's multiply out the 2x squared minus 2 quantity squared. That'll give us the integral from -1 to 1 of 4x to the 4th minus 8x squared plus 4 dx. And the integral is 4/5 x to the 5 minus 8/3 x cubed plus 4x, and we evaluate that from -1 to 1. That means we compute the integral at 1, which means 4 times 1 to the 5th over 5 minus 8 times 1 cubed over 3 plus 4 times 1, and then we evaluate the integral again, but at -1, which will give you 4 times -1 to the 5th over 5 minus 8 times -1 cubed over 3 plus 4 times -1, and that computes to 64/15.